we want to make a cube to move, we need to create a visual primitive here. So we're going to the hierarchy, we're going to right click, 3D object, and then cube. Okay, so a cube has been added to our scene. It's very simple, a very simple 3D mesh. Let's rename this cube to player, and we're going to change the player's position to be 0, 0, 0. Okay, so it's going to be standing in this position. And better than this, let's change y to 0.5, so it's going to be standing a bit over the floor. Okay, and if we want to change the color of the player, we need to create a new material. So we go to the assets panel, right click, create material, and we want to change that to player material. Now in the inspector, we're going to change the color of this material to something different, like yellow, for example, something that's going to be very easy to spot, and we're going to drag and drop the material inside the player in the scene. Okay, and now we need to create a script for the player, just like we did with the game controller. So we right click, select create, then C# script, and we're going to name this player. Now we just have to wait for the compilation to complete, and once it is done, we just double click the player to open the script. Okay, and remember, this is very important. This script needs to be attached to the player, so we're going to drag the player script file and drop in the player game object. Okay, and if you take a look at the inspector, we now have the player script component in here, so we can start making a logic for this player to move. Okay, so let's put in action what we learned by using the game controller. Okay, we're not going to use these input calls in here. Okay, it was just for testing. I'm going to leave hello world here. And in the player, we want to make it move to the left and to the right, to either of these directions. Okay, so we want to test the movement to the right. So we're going to type if input.getKey. Remember, it's just get key because we want to process when we are holding down a key, and the parameter is going to be right. Okay, so input.getKey right. Now, how do we make the player to move? If you look at the player game object, and any game object that you have in the scene in general, you have a list of components in this game object. In the case of the player, we have the cube, which is mesh filter, which is the 3D data. We have the box collider, which is used, as the name suggests, for collisions. We have the mesh render, which is used for drawing the cube. Okay, if you don't have this, you can see no cube at all. And we have the player component. But we have the transform component, and this is the most important of them because it deals with the position, the rotation, and scale of the player. So right now we have the player in the position 0. But if we want to make the player move horizontally, we have to change this value in the x-axis. Okay, we can change it to a negative number if we move to the left, or to a positive number if we move to the right. And the important thing here is the position is a property that contains 3 values. Okay, and this collection of these 3 values is a vector 3. Okay, it's a collection of the position in the horizontal axis, in the vertical axis, and in the depth axis, in all of these 3. So to make the player to move to the right, we need to do a few things. First of all, we need to create a variable for this player to define the moving speed. So in the top of the class definition, we type public float speed equals to something like 3.5f. Okay, so what I just did was declare a variable. The variable name is going to store something. Okay, so the name is speed. The variable is going to store a floating point number. This variable is public, so it can be accessed in other classes and in the Unity editor. And we already start by assigning the value 3.5. Okay, that's 3.5f, 3.5, and a semicolon to finish this statement. And for the update, this is what we have to do. We're going to type transform.position plus equals, and some people might think we just have to type speed here. Okay, if you try to jump ahead and you say that transform position plus equals speed, that is going to increase our position in the right axis. But if you go to Unity, you're going to see that there is an error. It says the operation plus equals cannot be applied to operands of type vector 3 and float. Okay, so why is this happening? When we type transform here, we are accessing the transform component of the player game object. Okay, so imagine you are here in the script, you press the right button and then it says transform. Okay, so you jump to this component here. And when you type dot position, you access the position property inside the transform component. Okay, so when you type transform dot position, you access this here. This property can be read or modified. If you just want to read the values, you can, but if you want to change these values, you also can. When we type plus equals, it means we're going to increase this. We're going to sum whatever we have here to something else, and the result is going to be stored here. So for example, let me just make a very quick example here. Imagine the position of the player is 10, 5, 0. When we type transform.position plus equals to another vector like 2, 0, 0, that means that these two vectors need to sum. Okay, so we're going to sum the x values, the y values, and the z values. So the result of this sum is going to be 12, 5, 0. Okay, and this result that we have here is going to be stored in the transform.position. That's pretty much what we're doing here. However, the important thing that you have to realize is that this sum is executed with things of the same type. Okay, position is a vector 3, but speed is a floating point number. Okay, so you might be asking now, okay, why do we have then this speed variable? Okay, because of this. We're going to type here vector 3 dot right multiplied by speed. Okay, now position is a vector 3, and vector 3 dot right is a vector 3 as well. Okay, and as you can see in the summary, this is a shorthand for writing vector 3 1 0 0. So it's just 1 in the horizontal axis. And while both of these values are vector 3's, this one is a point. Okay, it's a position, and this one is a direction. Okay, so that is a vector. Imagine that is an arrow that contains a size of 1. And 1 is a great number when you're developing games, because if you multiply 1 by anything, the resulting operation is still that 1. So if we have vector 3 dot right and we multiply it by speed, that means we're increasing the size of this arrow to make the player move faster. Okay, so that is enough for making the player move, but there is one more detail. This operation is being executed inside the update method. So different devices, okay, so devices that have a faster processor or a device that contains a slower processor are going to call the update method different times each second. Okay, so a quick one might call update 60 times each second, and a slow one might call the update method just 10 times each second or just 5 times each second. Okay, which is not good. So that means that players with a faster device would have a better match, a better experience, which is not very fair. Okay, so we need to make sure that we try to make all experiences as similar as possible. So to do this, we're going to multiply all of this by time dot delta time. Okay, and when we do this, it means if you are running on a fast device, time dot delta time is going to return how many seconds have passed since the last frame. So this is going to be a small number. Okay, so the update method is called more times in a faster smartphone, for example, but the player is going to move shorter distances on each of these calls. Okay, in a way that a slow device is going to move longer distances, even though the update method is called lesser times. But in the end, the result of all this discussion is that they're both going to travel the same distance over time. Okay, so now if we save this and we go to Unity, let's wait for this compilation to complete. This error is completely disappeared. Okay, and if we press the play button, there we go. If we press the right arrow, then the player is moving to the right, okay, which is exactly what we want. Okay, we can already give input for this player. And notice that you can change the speed variable without having to recompile the code. So if I put speed as 1 here in the editor and I press play, the player is moving much slower than before. Okay, and even at runtime I can change that to other values, okay, like 2, maybe 4. Right, we can just find whatever is going to be fine. I think 3.5 was fine in the beginning. Okay, and now let's make the cube move to the left. Now we put if input.getKey and we type in left, okay, between parentheses, as this is a parameter of the getKey call. We open and close curly braces. Then we're going to do the exact same thing here. Okay, there are two ways we can do this. One way is to get exactly what we added here. Okay, transform.position vector3.right multiplied by speed multiplied by time.delta time. But instead of using plus equals, we can type minus equals. So we're going to decrease. Okay. If we save this and go to Unity and wait for this compilation to be finished, we can press the play button, and since the direction is now the opposite of right, it's going to be left. So if you press the left button, the player moves to the left, and right to the right. However, I think it's better not just change signs. Okay, we can use plus equals here, and instead of vector3.right, we use vector3.left. Okay, it's going to achieve the exact same effect. If you save this, go to Unity, wait for the compilation, and press play, then the player is going to move to the right and to the left just as it was before. Okay, in the exact same way. So now that we did the movement to the left and to the right, let's take the moment to save the scene. And in the next video, we're going to make the player to be able to jump. So we're going to apply some physics to it. See you soon.